We did the skull. There are all of these holes and openings in the skull, and we call them foramen, or foramina, for plural. Those foramen in the skull, like the foramen lacerum and the foramen ovale, remember all of the jugular foramen, right? All of those foramen are there so that nerves can pass from the brain to the face, the neck, and then one of them will go down to the abdomen eventually. Those nerves that come off of the brain to do all of that are called cranial nerves. And the cranial nerves are part of the peripheral nervous system. They are nerves with names, so all the named nerves that we have are part of the PNS, peripheral nervous system. In your packet, there are 12 pairs of cranial nerves, which means there's 12 on the right side, 12 on the left side of the brain, and they're mirror images of each other. So there are 2 of each nerve. So there's 24 cranial nerves total, 12 on each side. They each have a number, a Roman numeral. They have a name, and they have a function, and they have a foramen that they pass through. So for those 12 nerves, you need to know all those things, okay, for both lecture and for lab. You can get that out of your lecture notes, you can get that out of the textbook. There's plenty of places that have have lists and tables. But here's the list. Olfactory, optic, oculomotor, trochlear, trigeminal, abducens, facial, vestibulocochlear, glossopharyngeal, vagus, accessory, and hypoglossal. Big words. But if you know the language, it won't be that hard. Okay? So, olfactory, what is olfaction? Smell. So that's this. So that would be a sensory nerve for smell. Right? Optic, sensory for vision. Right? Oculomotor. What do you think that one does? Oculomotor. No, oculo is eye still. Ocular. Moving the eyeballs, that's right. So you know, your eyes move back and forth, up and down, on diagonal even sometimes, right? You can look up and over. And the eyes move because of the muscles that are attached to them. And those muscles are innervated by the oculomotor nerve. Also the trochlear nerve and the abducens nerve, those 3 nerves all move the eye. What direction do you think the abducens nerve moves the eye in? It abducts, it moves it laterally away from the midline. Facial nerve, vestibulocochlear is for hearing and balance. Your cochlear system is your hearing, and your vestibular system is your balance. All done by the same nerve. Glossopharyngeal is a nerve of the throat and tongue. Vagus nerve is the only nerve out of these 12 that go down into your abdomen, so it goes into your chest, into your abdomen. Accessory nerve is totally motor, and it goes to your trapezius muscles and your sternocleidomastoid muscle that you learned about a few weeks ago. And then nerve 12 is hypoglossal. That is a pure motor nerve that moves your tongue. Anytime you see glossal, it means tongue. The glossopharyngeal was tongue and throat. Okay, so now they give you some mnemonics here, and the mnemonics are great if you use them correctly. But you know, a mnemonic like this is good to keep an order of things. But you know, it might be just easier to remember the word versus the mnemonic. So it says, oh, to touch and feel very good velvet, heaven. Each one of those words, the first letter of each of those words is the first letter of the nerve, right? And as you're going to find out, I may have told you before, people who make these mnemonics up there, medical students, they have filthy minds. Okay, so this one was cleaned up a little bit for family audiences. So you can imagine the V is not really velvet. So that skull over there, if you kind of slide that one over, but don't really slide it, lift it. It's like chalk on a chalkboard. Nails on a chalkboard. If you look at this, the yellow pieces are the nerves. Red are arteries. And the nerves are shown through the foramen they go through. Okay? And on the front, you can see how they come out of the eye, the orbit as well, and go down the maxilla and mandible. Okay? So the first thing you should do is kind of get a bit your bearings, right? Just think of the bones of the skull that you went over in the second part of the course, and then use your atlas to find the foramen, and the nerve that goes through the foramen would be the nerves in this chart right here. So on page 3, I guess it is, it gives you the nerve and the foramen that goes through to leave the skull. So remember the olfactory foramen we found in the ethmoid bone in the thing called the cribriform plate, which was like an island in the center of the frontal bone, if you remember correctly. Well, that was here. And as you can see, there's a nerve right on top of that cribriform plate, and this would be representing nerve 1. Right? The olfactory nerve. If you look in here, you'll see kind of a thick yellow wire. And it goes through the little round frame, the canal in the back of the eye. And that's represented for nerve 2, the optic nerve. Remember when we did the skull, the optic nerve, I kind of showed you, comes through and crosses here? Remember that? Well, if you trace that all the way back, that's the optic nerve that does that, but you can see how it's going to cross to get to the back of the skull where the visual cortex is in the occipital lobe. So that's the first part. If I were you, I would maybe take a picture of this, and when you're studying at home, try to match nerve for foramen. Okay. All right, so that's the first few pages. And that's pretty much bookwork, all right? So if you go down to page, well, there's no page numbers on this table. Keep going, you'll see it says there is a mnemonic used on the top of about 3 or 4 pages in. You see where it says some say marry money? That's what you're looking for, some say marry money. This is a great mnemonic. I love this mnemonic because it gives you the order of the nerves, and the phrase is, some say marry money, but my brother says big brains matter most. Again, the B for brains is not the original B. It was cleaned up. But if the word starts with an S, it's a sensory nerve. If the nerve starts with a B, or rather an M, it's a motor nerve. And if it starts with an M, it's motor. And if it starts with a B, it's both sensory and motor. See how that works?
B is what? Both.
So,
Motor, sensory,
if it starts with an S, the word some,
sensory.
see, it's a sensory. Say, sensory. M for marry is a motor. M for money is motor. But B in but is both sensory and motor. So nerve 5 is both sensory and motor. That's a way to remember which ones do which function. Okay. Now, right underneath that, there are 4 nerves listed: 3, 7, 9, and 10. Those cranial nerves also give what's called parasympathetic innervation. Remember, in the beginning of the semester, you should learn about fight or flight. We may have talked about that in lab too, but in lecture you should have gone over that. And remember, fight or flight is your body getting ready to either run away or fight to protect yourself. But either way, the body has to prepare itself to do either of those things. So the eyes have to dilate, and you breathe heavier. Your pulse starts to race because you want to get blood to your muscles, and you don't go to the bathroom and you don't pee in your pants because that would slow you down when you're running. That's all sympathetic nervous system. That's why sympathetic nervous system is fight or flight. Parasympathetic, on the other hand, is the opposite. So if the sympathetic speeds something up, the parasympathetic slows it down. If the sympathetic opens up something, the parasympathetic closes it. So it's the opposite of the sympathetic. So if you can remember fight or flight, what all the fight or flight things are, the opposites are the parasympathetic nervous system. So instead of fight or flight, we call the parasympathetic rest and digest. Because you're sitting on the couch watching TV, you're eating and you're peeing during commercials and all that stuff is parasympathetic versus fighting and running away, which will be sympathetic. Now, the reason why I say this is that these 4 cranial nerves are the only 4 cranial nerves that do a parasympathetic function. So if you look, cranial nerve 3 does the sphincter of the pupil and the ciliary muscle of the eye, the lens of the eye. So the sphincter of the pupil. So when you shine a light into the pupil usually gets smaller, constricts, or dilates. Right? Dilation is sympathetic. Getting smaller is parasympathetic. So when you shine a light into an eye, the doctor shines the light in the eye and looks at your pupils, he's checking to see if his nerve 3 is working properly. Nerve 7, lacrimal means tears, and mandibular and sublingual, those are salivary glands. So nerve 7 controls those things. Nerve 9 controls the big parotid gland, which is on the side of your cheek in front of your ear, and that is where most of your saliva comes from. It's the big salivary gland. And nerve 10 is the vagus nerve, and it goes down in the thorax and the abdomen, and it slows down metabolism, or it can dilate a blood vessel, things like that. Okay? So that's kind of like the bookwork for this lab. Then it says full sheep brain and a cat. So let's look at the sheep brain, and I'm going to show you all the parts of the brain that you need to know. The first thing I want you to recognize, one is that this brain is a whole brain, and this brain is a half a brain. What kind of cut would that be? Sagittal, because remember, the cut separates right to left. Okay? So the left side of the brain is missing from this one. Right? You can kind of tell that the front is here, and the back has a spinal cord where it comes out of. Because that's another way to say it, which is front and back. Also, the back side has this thing here called the cerebellum, and that's in the back of the sheep. In the human, it's actually underneath, like that. Because remember, we stand upright. The cat is 4-legged. And this structure here, we'll find out what it does later, but if you notice that there's a covering around this whole brain. And this covering actually goes around the entire brain, but it's been removed on one side so that you can see underneath it. This looks like kind of like saran wrap. This covering is called the dura mater, D-U-R-A. And then there are two layers underneath that, the pia mater and the arachnoid mater, and those three together make up something called the meninges. And the meninges are just three layers of connective tissue coverings that protect and enclose the brain and spinal cord. Okay.
Excuse me.
The thick one is the dura mater. The pia mater is the thinnest, and you can kind of see it. If you kind of squeeze the brain a little bit, you'll kind of see another layer there. But if you ripped it off, you would rip the brain tissue off. So the pia mater is directly adherent to the tissue. You can't remove it. Okay. Did you have a question? I thought I heard somebody say something.
The one, Dura what?
Dura mater. D-U-R-A-M-A-T-E-R. Means tough mother. Dura mater means tough mother, which is why this is the thickest of the three.
It's not the same like meninges, you said?
Meninges. The three.
It's the same one.
Well,
Dura mater.
the dura mater, the pia mater, and the arachnoid together make up the meninges.
Oh, okay.
Okay. So, this is the cerebrum. This is the cerebellum back here. These are the meninges, like we said, and this is the spinal cord, beginning of the spinal cord. The surface of the brain has all of these nice grooves and hills, kind of like hills and valleys. And believe it or not, each of these have a name. Each of these grooves and each of these hills have a name. And guess what? You don't have to know them all. First thing I want you to know is that the hills are called gyri. The word is actually gyrus, G-Y-R-U-S. One gyrus or many gyri. So the gyrus is like the hill, and on either side of each gyrus, there's a valley. Those valleys are called sulci, or one sulcus, S-U-L-C-U-S, sulcus. So there's a sulcus on either side of each gyrus. And what do you think that does to the surface of the brain by having all of these hills and valleys?
Gives you more surface area.
It gives you absolutely more surface area. So the more surface area you have on the brain, the more the brain can do, right? The more function it can have. All right. On these nerves, on these brains on the bottom, and the cranial nerves that we just talked about, all come off the inferior surface. And these strings, big thick ones, and also some little ones, those are the cranial nerves. Okay? But I'm only going to hold you responsible for a few of them. So the ones I'm going to hold you responsible for are number one, which is the olfactory bulb, which is this piece right here. That's the same yellow thing that I showed you in the skull. This is for smell, right? Olfaction. Nerve 2 is, move this out of the way. Nerve 2 is this piece right here, and this piece right here. And as you can see, nerve 2 comes this way, nerve 2 comes this way from each eye, crosses, and you can kind of see where it crosses. If we actually you can see where it crosses, you can see the fibers, and it goes to the occipital lobe in the back of the brain. Okay? So this is 2, so it's 1, 2, and this one here is this big one, this one, and this one. You notice it has 3 parts to it. 1, 2, 3. What nerve, if you look at the nerves on the names of them, which nerve do you think has 3 parts? Trigeminal. Tri means 3. So this is the trigeminal nerve. Okay, and the other ones are variable. I mean, they're there, but sometimes they're not they're messed up, and you can't really see them that well. So those are the. I'm only going to hold your responsible for those big ones. Okay. Now, if we look at the sagittal section, this is a little more interesting. The cerebrum is the biggest part right here. And this is the cerebellum. And if you notice, and you kind of look closely, and if you want to zoom in, the cerebellum looks like a tree. Or I even think it looks like broccoli or cauliflower. And this appearance of the cerebellum is called the arbor vitae. ARBORVITAE. What does arbor mean? Tree. And what is vitae? Your curriculum vitae tells people the story of your what?
Life.
Your life. This is called the tree of life, the arbor vitae. Now, this part of the brain right here is the oldest part of the brain. This is called the brain stem, which has 3 parts to it. It has this part here, which is called the medulla oblongata. Directly in front of that is the area called the pons, P-O-N-S. And then if you were to kind of, let's see if I can do this one. If you were to bend this a little, you'd see these bumps on the inside in here. This is called the midbrain. So the brain stem has the medulla, the pons, and the brain stem. Okay, and in lecture you'll talk about what each of these things does. Okay, but this is where most of your breathing and heartbeat and all those stuff that's automatic that you don't think about happens from there. Okay, the thing that's not part of that life mechanism are these 2 bumps, those 2 big bumps that are in the midbrain. And these are called the superior and inferior colliculi. And if you look at them, you can kind of see there's a big bump and a small bump underneath it. And those are the reflex areas for hearing and for vision. So the superior colliculus is for vision, the inferior colliculus is for hearing. And this is where some of that processing goes on to figure out what's being heard or seen. Right behind that, if you go upward over, you see this little thing right here. So sitting right on top of the midbrain is this nice little gland here, which makes something called melatonin, and it's called the pineal gland. And it's the melatonin that comes from here allows you to go to sleep. Right? You see in CVS, the melatonin supplements and all those things that you buy. Well, the people who have trouble falling asleep, they can take melatonin to try to help them go to sleep. Okay, going further southward, right? Here's the spinal cord. Notice that the spinal cord has a groove on the inside of it. All right, see that right here? That's called the central canal. It's kind of in the center. Make believe it's in the center. And in the central canal, we're going to find fluid that's actually going to come from up here. So that central canal is going to hold what we call cerebrospinal fluid. In the center of the brain, you see this big open space. Okay? This big open space is called a ventricle. Just like in the heart, a ventricle holds blood, but the ventricles in the brain holds cerebrospinal fluid. The cerebrospinal fluid makes a great protector, and it keeps it moist, and it keeps it nourished and all that. So the cerebrospinal fluid begins up here in the lateral ventricle, goes through a couple of other sections, and ends up in this canal of the spinal cord. So all of that fluid that's bathing the brain is also bathing the spinal cord.